Hey folks, I've got another example of circuit analysis. This one will be fairly brief. Again, if you have this packet, that's great. If you don't, I would suggest you pause the video for a moment and go ahead and copy the diagram down. All right, um, we're going to do the same thing we did in the last one. There are some differences in this one in that what we give you, okay, but otherwise the process is the same, okay. We'll start with assigning currents. So I1 is given to you on the far left there. It's up, and it's that number right there. The other two currents and the other two parts of the circuit we're going to have to guess on. So I will guess for I2, I will guess down, and for I3, I will guess down. Now again, if you get that wrong, it's not a problem. Oh, sorry about that. Not a problem. Uh, you just you'll get a negative value, and you just know that it points the other way. Okay. All right, so we'll start with Kirchhoff's junction rule. I always start with that. You don't have to, but it tends to be easier. And I'll look at that junction right up there. So in this case, I1 is going into that junction, and I2 and I3 are coming out of it. So I know that I1, which is 37 over 24, equals I2 plus I3. Okay, so I've got one equation, but I got two unknowns. And by the way, it's going to be a third unknown. We want to know what this resistance is right there. So we are going to have three unknowns eventually. We're going to need three equations. For equations 2 and 3, I'm going to use Kirchhoff's loop rule. And you can pick any loop you want. We have a left loop, we have a right loop, and we have an outer loop. As long as you pick two loops that together cover every part of the circuit. So I'll start with here, and I'll do the left loop, okay? And if we go clockwise around that left loop, okay, so we go with the battery, so from the minus to the plus, so let's say positive 50. Then we're going with I1 through that resistor up there, so it's a minus. You're going with the current, so it's a loss in voltage. You're going downhill, so it'd be minus 10 times I1, which is 37 over 24. And then we take a right turn and go down through this battery. We're going from the minus to the plus, so that's a positive 20. And then we go with I2, so we are losing voltage again. We're going downhill, so minus 30 I2. And then we then go through the 20 ohm resistor, and that's I1, and we're going with I1, so it's a minus again, so minus 20, and then I1 is 37 over 24. And this all has to equal 0. Well, if you look at this, what's the only unknown? I2. Okay, so I'm not going to belabor all the algebra with you, but if you do all the algebra, I get 19 over 24. I kept it as a fraction, amps. And it is down. We guessed correctly. You get a positive answer. Okay. All right, so then I know I3, right? If I2, I know this, I now know I3. So I3 is going to be, if you subtract 37 over 24 minus 19 over 24, you get 3/4. So I3 is 3/4 of an amp. All right. So then to figure out this unknown resistance, I've got to either use the left or the right loop or the outer loop. Doesn't matter which one. I'll start here again, and I'll do the outer loop. So the cool part is the first two terms are identical to what we had before. So we have a 50, we're going with that battery, and then minus the 10 times I1, which is 37 over 24. Okay, but not now we're here, now we're going this way. We're going with I3, at least, yeah, and we got I3 right, by the way. We got a positive answer, so we guessed correctly. So we're going with I3, which is a drop. So minus R times 3/4, that's the current. And then we go back through here, which is I1, so it's minus 20 times 37 over 24, and that all has to equal 0 again. Basically the only unknown is R. If you do the algebra, I got R is 5 ohms. Okay, so that's your unknown resistance there. So again, that's a little practice in using circuit analysis to solve for unknown currents, and in this case, an unknown resistor. Hope that example was helpful, and thank you very much.